In wild natural soils, the environment is in a state of constant, violent flux. The physical ground can shift from heavily flooded and saturated with nutrients to bone dry and completely barren in a matter of days. Traditional active microbes cannot survive these rapid changes. Bacteria that live as active vegetative cells, those that are awake, fragile, and constantly feeding, quickly die the moment their local food supply vanishes or temperatures spike. But specific bacteria found in the dirt, known as soil-based organisms, have adapted to outlast these environmental disasters. Instead of maintaining constant activity, they spent millions of years developing a specialized survival strategy. Over time, they became highly adapted survival specialists. To endure nature's most brutal extremes, these organisms evolved a resilient defense mechanism that allows them to simply pause their existence and wait for a better day. Down in the microscopic scale, when a severe environmental disaster like extreme heat or a prolonged drought hits, these soil bacteria face an immediate existential threat. They respond using the dormancy and reactivation system. Rather than attempting to flee, the bacteria rapidly construct a multi-layered vault entirely around their own DNA. It shields its fragile core by building a rigid cortex, wrapping it inside a hardened outer protein coat. Once sealed, metabolic shutdown begins. The organism turns off completely. In this dormant form, the microbe requires zero food or energy. The vault closes tight against the outside world. Hitting this biological pause button makes the sleeping spore incredibly durable, protecting against extreme cold, intense heat, and toxic chemicals. When we consume these organisms as supplements, they move from the harsh wild dirt directly into our own biology, dropping immediately into the human stomach. This acidic barrier is engineered to break down food and destroy incoming germs. Standard, fragile probiotic cells are quickly dissolved and killed in this liquid. But the dormant soil organisms are entering the transit phase, the journey down our digestive pipeline. Safely locked inside their armored shells, they treat this acid bath as just another temporary environmental stressor. While unprotected vegetative cells are chemically crushed on contact with the acid, the soil organism's impermeable inner membrane securely locks out the digestive juices and deflects the chemical attack. Their ancient evolutionary vault is the reason nearly 100% of these specialized spores survive the dangerous gastrointestinal pipeline completely intact. After surviving the stomach, the sleeping spores drop into the small intestine. This is the official reactivation zone, an environment filled with moisture, warmth, and abundant nutrients. The exterior of the vault is lined with germinant receptors. When these microscopic sensors detect the presence of local digestive juices, like bile salts, they send a clear biological signal that the journey through the acid is over. The physical awakening happens in minutes. The spore rapidly absorbs water, breaks apart its rigid outer cortex, and sheds its armor to stretch out as an active, living cell once again. The bacterium returns to life, restoring its active metabolism and growth. This beautifully timed waking sequence ensures that the organism arrives in its active state, exactly where it is most needed, ready to set up its temporary home and get to work. Now fully awake, these soil bacteria do not permanently colonize the gut. Instead, they join our native microbial community as a temporary security force. Their first job is pathogen exclusion. By taking up physical space and producing natural compounds called antimicrobial peptides, they actively force out harmful, gas-causing invaders like E. coli. Their second job is cooperative. They engage in cross-feeding, breaking down complex dietary fibers into simple sugars to feed the other native microbes living in our intestines. As native bacteria consume those sugars, they produce short-chain fatty acids that fuel the mucosal firewall. This protective layer uses those fatty acids to repair the gut barrier, strengthening the intestinal lining and soothing drug-induced digestive slowdowns. By mastering a dormant survival mechanism in the harsh wilderness, these dirt-borne organisms have evolved into highly durable and resilient guardians for the human gut.